abbreviations for those: SSS, SAS, ASA, and AAS. Apostles for triangle congruence. Notice there is no ASS congruence theorem or postulate. Anyways, instead of showing that all corresponding parts of two triangles are congruent, we can use other methods, and these could be your reasons in a proof. So the first one we're going to talk about is side-side congruence, and I have the thing listed there. If three sides of one triangle are congruent to three sides of another triangle, then we would say that those triangles are congruent. Okay, so example here with your triangles to the right here is you can see right off the bat that, like, just by the hash marks, that side ZX is congruent to side AB. And we could also say, because the double hash marks, that side AC is congruent to side YX, or to side ZY, I'm sorry. And then we could say that side YX is congruent to side CB. Okay. And so since we've been able to prove that all of those sides are congruent, then we could say that these triangles, triangle BCA is congruent to triangle XYZ, sorry, XYZ. Okay? And our reasoning then would be, for our reason in a proof, would be side, side, side. Okay? Notice that in this part here is where the order matters of your letters. They don't really, you can see I kind of did that on purpose, jump from first triangle to the second triangle, and then second triangle, first triangle, vice versa. Because that one doesn't really matter, you're just listing the congruent sides. But when you put it into the congruent statement, then the order matters. So that would be an easy side, side, side to show that. Okay? Next one we're going to talk about is side, angle, side. Before we do that, let's just take a look at what an included angle is. So an included angle is an angle formed by two adjacent sides of a triangle. Okay? So, and I guess I should put in there, just to add it in there, two adjacent, and they're also congruent. Okay? So you can see in your diagrams here, angle D is in between two sides F and E, and angle B would be the included angle here. Okay, so they're included, and we're saying congruent to a corresponding triangle, basically. So side, angle, side congruence that we would say is side. You can rename it SAS, just like over here you could rename this one side, side, side. Okay, so on this one here, what is side, angle, side congruence? This one is if two pairs of sides and the included angles are congruent, then the triangles are congruent. So you've got two pairs of sides and the included angle have to be congruent. So in this one, we're taking a look at the sides first. So let's say you had side ED. Yep, side ED has a double dash mark, so let's start with that one. And that would be congruent to what side in the other triangle? It would be CB because of the double dash mark there. If I looked at the angle, included angle, D and B would be included there. Angle D would be congruent to angle B. And then another side, we would say that side AB is congruent to side FD. So if you look at these, what you have is you've got a side, an angle, and a side, which is basically SAS. So according to this, we could write our congruent statement and say that triangle EDF is congruent to triangle CBA, And the reasoning here then would be side, angle, side. Okay? So that's two of them. That's two of them, just kind of looking at it. All right, so now let's talk about what an included side is, what an included side is as we get into the other two. An included side is a side located between two adjacent angles of a triangle. So in this case, and I know this isn't on your sheet, on your sheet anywhere, but if you just want to write it in somewhere, it might help you to kind of figure that out. So if we say name the included side for this triangle. So what's the included side between angles A and B? So if we look at angle A right here and angle B here, what side is between those? Well, it's this one right here. So we'd say side AB. Okay. What about the next two? Let's say we said side angle B and angle C. So if it's angle B, angle C, that would be this side here, BC. Okay? And then finally, the last one would be between A and C. Here's angle A, here's angle C, so it would be side AC there. Okay? Those would be the included side in between those angles. And one thing to think about here, because it'll show us kind of where we're headed in this direction, is if you had, say, this angle here was congruent to an angle on a different triangle, and then this angle here was congruent to angle on a different triangle, and this side was congruent to those, to a corresponding side on a different triangle, well, then we could say angle, side, angle, right? Angle here, the side here, the angle here, and that's kind of where we're leading into it, is angle, side, angle. So angle, side, angle congruence, again, is going to be, you can rewrite it ASA if you want, ASA. That is going to tell us that if we have two pairs of angles and the included sides are congruent, then those triangles are congruent. So you're talking about two different triangles here. You can see here that we've got angle T on one triangle is congruent to angle G on the other triangle. We also have a side, TR, with this dash mark here, is congruent with CG on the other side. And that would be our included side. And then finally, we have another angle, the double arc with angle R and angle C. Okay, so because of that, now we're listed angle, side, angle. And so we could say that triangle, let's call it WRT, would be congruent with triangle. And now here's where order matters. So W would have to go with H, and it would be HCG because the C would have to go with the R, and the T and the C would be together, right? T and the G, sorry. T and G would go together, and R and C would go together. So because of that, we could say that those are congruent because of angle, side, angle. Okay? And the last one today is angle, angle, side. So on angle, angle, side, we're looking at, again, we can change this to AAS, angle, angle, side. And this time we're talking about two pairs of angles and a non-included side. So the difference between angle, side, angle, and angle, angle, side is that the side we're talking about that's congruent is not included. It's not between the two angles that are congruent. Okay? So the example here would be you've got angle A and angle K that are congruent. You can show that with a single dash mark. You've got angle L and angle B. And then you've got two sides. You've got side JK and you've got side AC. However, it's not included, so we'd be talking about angle, angle, side. So when I wrote this one out, I would say triangle, let's call it LKJ. Just to show we can name it with any order, it's just the order matters now, just depending on what we called the first triangle. And that would have to be BAC, right? BAC. Okay, and the reason for that would be AAS. All right. So that is our theorems, the four of them. So let's take a look at these. The key here is we're talking on number one here, we're just talking about side angle side or side side side. So those are the answers. And let's look at letter A first, okay? Letter A. Well, we don't see anything with angles congruent, but we do see that we've got a single dash mark here and here. We've got a double dash here and here, so that's two sides. But what about the third side? Well, both triangles have US as a side. And so because of the reflexive property, it would be congruent to itself. So that would be the third side. So that would make it a side, side, side. Okay, and in the congruence statement that we would write here would then say triangle RSU, the one that's kind of laying on top of it, would be congruent to triangle TSU. And you just have to be careful of the order there and make sure that you're listing the congruent sides with one another. And then let's go down to the letter C for this one. Okay, because this one's a one you see all the time, these bow tie type shapes. All right, so in this one, you can see two sides listed. You got a single dash mark here, and you've got a double dash mark here. We don't necessarily have a third side, but what about an angle? What about an angle? Well, in this case, we do have vertical angles. Remember, vertical angles are congruent, so those two angles would be congruent. So now we'd be talking about side, angle, side. And so we would write a congruent statement saying triangle QRS would be congruent to triangle TUS. Okay? The side, angle, side. Skip B and D. You guys can do those on your own. And now let's take a look at number two. Number two basically is talking about angle, angle, side, and angle, side, angle. So in this case, what we're going to look at is, we could probably do both of these really quick. Again, the bow tie shape is going to tell me that there's an angle that's congruent here. So now we know it's angle, angle, side, or angle, side, angle. So the question is is that side between the two angles? Well, in this one, it is not. Okay, you can see that the sides that are congruent are not between the two angles, so we'd say angle, angle, side. And so we would say triangle NKJ is congruent to triangle LKM. All right, and over here on letter B, we would look, you can see this one, that this side here is between the two angles, so this would be angle, side, angle. And we would say that triangle BAC is then congruent to triangle EDF. Okay? So that is it for 4.4 and 4.5, which we kind of combined into one lesson because it's a little bit different this year without the proofs. So that should do it. And again, try to finish up any ones that we didn't finish and bring your questions to class so we can help you out if there's something you didn't understand. Okay? Thanks a bunch. We'll see you next time.